Okay, hello friends. In this videos we are going to discuss regarding air refrigeration system. So air refrigeration system is basically a system that controls the property of air, like its temperature, humidity, uh, the other parameters like the motion or the moisture content. So the refrigerating devices like refrigerator and other air conditioning devices are compared with an standard efficiency. We call it coefficient of performance. So first let's look into the Carnot cycle, which is used as a ideal standard for comparing the efficiency of heat engines, while as we'll be looking into the reverse Carnot cycle, which is used to measure the coefficient of performance of different refrigerating devices. So first let's see at Carnot cycle. In Carnot cycle, I have drawn a PV diagram showing the Carnot cycle, which is very easy to understand. Here from 1 to 2 is a isothermal expansion process, 2 to 3 is an isentropic expansion. Again, the reverse of isothermal expansion is isothermal compression, and 4 to 1 is a isentropic compression. Okay, so here you can clearly see these are V1 is the volume at 0.1, V2 is the volume at 0.2, V3 is the volume at 0.3, V4 is volume at 0.4, and similarly the respective pressure at 0.1, 2, 3, 4 are P1, P2, P3 and P4. So if you see a TS diagram for a Carnot cycle, you will have 1 to 2 is an isothermal expansion process, 2 to 3 is an isentropic expansion process, and 3 to 4 is an isothermal compression, and 4 to 1 is an isentropic compression. So and the efficiency for Carnot cycle is given by 1 minus T2 by T1, where T2 is the temperature of the sink and T1 is the temperature of the source. So after looking at Carnot cycle, it's very easy to understand reverse Carnot cycle, which is being used in order to calculate the coefficient of performance of various refrigerating engines. So it's an ideal cycle, and no any refrigerating devices work on this principle, because this is the highest possible coefficient of performance that we can get. So it's better to compare the coefficient of performance with respect to the Carnot cycle. So in a Carnot cycle, the first process from 1 to 2 is an isentropic compression, 2 to 3 is an isothermal compression, 3 to 4 is an isentropic expansion, and 4 to 1 is an isothermal expansion. So the diagram is very similar to the Carnot cycle, just the process are reversed. For example, 1 to 2 is an isothermal expansion, but we will have 1 to 2 as a isentropic compression. Okay, so here isothermal expansion, we have isothermal compression, isentropic expansion, here we have isentropic compression. So this is the PV diagram representation for reverse Carnot cycle, and below we have a TS diagram that represents the reverse Carnot cycle. Here we have from 1 to 2 is an isentropic compression, 2 to 3 is an isothermal compression, and 3 to 4 is an isentropic expansion, 4 to 1 is an isothermal expansion. And the COP for this reverse Carnot cycle is given by T1 by T2 minus T1. So T1 is a greater temperature, here is a temperature which is higher, and here we have T1 minus T2. Okay, T1 minus T2. So this is all about reverse Carnot cycle and refrigeration system. Hope you like these videos. We will see more interesting topics in air and refrigeration. in the upcoming videos. And thank you guys for subscribing to my channel, and please do not forget to press the bell icon, and please comment and share the videos to the friends so that they can be having knowledge on air refrigeration system. Thank you.